good afternoon. Thank you for joining. Great to have you here. I know it's lunchtime, but appreciate the dedication. We're going to talk a little bit today about how to do streaming data transforms with WebAssembly. So if you're new to streaming data, we've got a quick intro for you. If you're new to WebAssembly, we've got a quick intro for you as well. So we will rush through this fairly quickly, but hopefully give you a nice overview of what we're looking at. So we'll first talk about data streaming patterns, then talk about why we can use WebAssembly, and then we'll take a quick look at how we can use and deploy that with Redpanda. So first of all, this is data streaming fundamentals. So we're talking about how we can stream data from one place to the other. And the common pattern for doing this is using something like Apache Kafka. And in its very simplest form, we've got data being produced in real time by a system somewhere. We're going to publish that onto a topic, and then we're going to have one or more consumers that are going to consume that data from that topic. And that really is about as simple as it gets in terms of data streaming. Now, if we want to scale that architecture, then what we start doing is we start adding partitions into our topics. And the more partitions we have, because the partitions are logically separate, we can then scale this out over many brokers. And this scales pretty much as far as the eye can see or you can imagine. And we can keep adding multiple consumers onto that as well. So many consumers consuming from the same topic. And in terms of how this might look, if you were running this in some sort of real-world scenario, we've got a scenario here where we've got some data being produced, some sort of telemetry data. We've got a little bit of JavaScript that's consuming, retrieving that data. It's pushing that onto a topic, in this case on our broker. We're then using Kafka Connect, and it doesn't have to be Kafka Connect. It can be any technology you want, but we're using Kafka Connect to read that data from our topic, and then we're going to write this to a database. So really simple, super simple streaming architecture. This is simple, it is scalable, it's going to be performant. The slight downside we got with this one is we have kind of accidentally coupled our source and our sink together, meaning that if something changes perhaps on our telemetry somewhere, then that's going to have a ripple effect down our architecture. And if we start adding in multiple consumers into this, then one change suddenly becomes amplified. So yeah, that coupling is something that can trip us up a little bit. And so what you end up doing, and in this case we've added in some sort of Flink consumer as well, just to decouple that source and that sink, we've now written a consumer and producer, a little bit of code that's going to take this and maybe transform it from one format to another. So super simple. I mean, this could be 5 lines of code, right, to convert from one format to another or do some sort of transformation. Downside of this is we've now introduced latency into the architecture. We've also potentially introduced network costs into the architecture. Particularly if we're running a cloud, we always need to be worried about network costs because there's always data charges in and out. Plus, we've then got a whole load of operational considerations of what we're going to do with this little tiny consumer producer code. Where are we going to host it? How are we going to schedule it? How are we going to monitor it? How are we going to scale it? How are we going to maintain it, patch it? All those things that kind of you don't really want to worry about. Now, a really super simple code that we had all of a sudden is a massive headache. And this is fine if we do it once, right? But then by the time we've done this 10 times or 100 times or 1,000 times of these tiny little bits of code floating around all over the place, we've now got this complexity we've got to look after. And we call this data ping pong, right? Data ping pong, this idea of data flowing in and out of our broker, sort of transitioning the boundary and stuff that we have to look after. And that is why at Redpanda we invented stateless transformations in the broker using WebAssembly. And so we can do all those little bits of transformation or filtering that you need to do inside the broker in process, meaning you kind of take away that operational complexity that you have with all those kind of data ping pong beforehand. We're going to do a quick run through on what is WebAssembly. If you haven't heard of WebAssembly before, we're going to do a quick run through. There are, I think, 2 or 3 talks over the next couple of days about WebAssembly. I can guarantee this time next year there's probably going to be double, if not triple that. WebAssembly is trending hot right now, and for very good reason. So WebAssembly, or WASM, or WASM, depending on how you want to pronounce it, at its simplest form is a binary instruction format for a stack-based virtual machine. What does that mean? Well, it's designed to be a very simple language, based on assembly language, that you can use for running arbitrary pieces of code in deployed applications. And it started off in the web browser, so you can now write any bit of code you like and run that in a web browser. But because it's basically this bytecode, this assembly language, you can then compile any language you can conceive of down into WebAssembly. And there are right now over 40 languages that you can run in a WebAssembly runtime. So whether it's C or C++ or Rust or whatever, if you can compile it, you can run it in WebAssembly, which is fantastic, right? The power of that, the power of having one runtime that you can run, like any developer here can write code that will compile down into WebAssembly. Interpreted language is a little bit different because if you've got things like Java or PHP or Python, you need to compile the runtime to run in WebAssembly as well. But guess what? Someone else has done that for you, so you don't need to have to. So it's a little bit less native, but you can still run any code you can pretty much conceive of in WebAssembly. It's designed to be super efficient because it is this bytecode. It's assembly language essentially you're running. It's a very simple language at its core. It comes down to the compilation power that you've got. It's running really close to the hardware, so it actually runs really fast. Because it was designed in the browser, it was designed out of the browser wars and kind of making browsers go much faster. So it's designed to be super efficient. It's designed to be open as well. So it's based on an open standard. It's designed to be backwards compatible and versionless. So essentially, as they add instructions, that's fine. You can keep using them. But because it's an open standard, you can then be confident that what you're running in one place, you can then run elsewhere as well. And it's also designed with safety in mind. So instead of having a really permissive model where you can run literally any code and kind of do damage, it's designed to be locked down from the get-go, unlike sort of previous attempts at sort of doing sandboxes and that sort of thing. It's locked down from the get-go, and you can then open up bits that you want to as you go. The bit that kind of turbocharges this is WASI or WASI or however you want to pronounce it, which gives you like a POSIX-like environment inside WebAssembly. So you've now got what looks and feels like a Unix operating environment. So you've got clock and arguments and all that sort of stuff. So now pretty much it feels like you're running in a container, dare I say. With that, and this is kind of what gives us the ultimate power, people are considering that WASM and WASI really are the future of cloud computing. And this is a quote from Solomon Hykes, who was one of the founders of Docker, saying that if this technology had been around back in 2008, they wouldn't have bothered inventing Docker. That's how sort of seriously sort of the movers and players in the industry are taking this. And I kind of think along sort of in terms of an evolutionary type approach, that if you imagine back in the early days of computing, we had mainframe computing, where you would rent some time on a computer for maybe 10 minutes or an hour or a few hours or whatever. We then kind of all got our own pizza boxes with utility servers, and that was kind of ubiquitous sort of in the 90s. We then went down the hypervisor route, and we had virtual machines and hundreds and thousands of virtual machines kind of floating around all over the place. Containers was the next big thing, and everyone's running stuff in containers. But WebAssembly is the natural evolution of this, right? We've now got something that is even more kind of simple and sophisticated that you can now run. And this is becoming ubiquitous in the cloud. It's not just the browser that it's being used on. It's now being used across cloud. And so we're starting to see WebAssembly pop up in kind of web technologies that you might be familiar with, and like Nginx and Envoy and Cloudflare. And because you can now write arbitrary code, and as I said before, any developer here can write code that will run in WebAssembly, you can now run plugins in Cloudflare that they are confident aren't going to take down their service, but you can now write your policies to run it in cloud services. And that's where Red Panda comes in. And so no conversation about data streaming is complete without talking about Red Panda. So if you haven't come across Red Panda, we're a company that produces a Kafka alternative. So built on C++, designed to be super fast, and used by some of the world's biggest organizations to really turbocharge their what would have been Kafka deployments before. So at its simplest, it is Kafka compatible, which gives us access to the whole Kafka ecosystem. But it is now a simple cloud-native architecture. As I said, written in C++, it is super fast and super performant and can run in up to a third of the compute power that Kafka runs. So you're running in a much smaller footprint. It also has multiple deployment options as well. So you can run this self-hosted. You can run it as a software as a service. We have this bring your own cloud model as well. Bring your own cloud means that we're essentially running a managed service in your cloud environment, so the data never leaves your cloud account, which is super efficient. We also have serverless as well, so if you want to just run and spin up topics as service, you can have a topic up and running within 60 seconds. And so Redpanda and WebAssembly really gives you fantastic power. You can use any language under the sun that's to write your plugins for Redpanda. We've got runtime limits, which means we can control. We can make sure that our service is safe and that your service is safe when you're running your code. And we've got that sandbox POSIX environment. We've got the ability to control the execution. There's a thing called gas metering, which doesn't have a British translation. It's still called gas metering over here. That means we can actually stop execution. So if you've got too many operations going on, we can kill that process and restart it. Other threads can do that, and we can bound the memory size as well, which is really useful. So what does this look like? Right now, you can go and write your, no pun intended, you can write your own transforms for Redpanda today in Rust and in Go. We have SDKs available for those two languages. We also have a number of pre-built transformations as well. So JQ, Avro, Redaction Engine, and regex. These are fantastic, actually, because when you're trying to do something really simple, and we talked early on about that really simple example of we want to just decouple two things, an input from an output. If you can just write a JQ expression that you can then deploy, run in your broker, suddenly you've saved that whole operational complexity that we had before of needing to write that code, need to wrap it, need to host it, schedule it, monitor it, maintain it, patch it, do all of those things. We're now just going to write a JQ expression, deploy that into your browser, job done. Not into your browser, sorry, into your Redpanda broker, job done. We now don't need to worry about any of that complexity. Avro conversions. Converting, for example, from JSON to Avro is something people do a lot of the time in order to save space. So that's something we've got pre-built. You don't need to write code to do that, whereas before you would have been writing code and deploying and managing that. Redaction, something that comes up more and more, particularly with GDPR and other regulations like that. We have a pre-built redaction engine. And so what you do is you say, here are the fields that I want to redact. Here are the redaction operations I want to use. So maybe I want to hash the last 3 digits. Maybe I want to completely mask it. Maybe I want to do some other operations. Maybe we just want to do a substitution. You can then configure that, deploy that. Again, you're not writing any code. This is just config at this point, but it's still running entirely within the Redpanda broker itself. And then regex, as simple as kind of doing a grep-based expression. Again, no code. You're able to do this in broker at very high performance as well. So to summarize, simple transformations, very fiddly to manage and maintain in a Kafka environment. We can simplify that with Redpanda. Redpanda using WebAssembly, and we've done a very quick tour on what WebAssembly is and the history of WebAssembly. And the use cases for this actually are tremendous, right? We can use this for enrichment. We've seen people actually load AI models into Redpanda, and then you can run messages through the model as you go, and then you add your predictions or whatever based on those machine learning models, all within the broker. Filtering, very common, routing, conversions, validations, all those types of things, and other stuff as well. You can use any language. Right now we've got Go and Rust, but any language you can think of, we can support that as well. And to top it all off, Redpanda, simple, powerful, and reliable. That is it from me. Thank you very much for joining. I'm happy to take any questions.